everyone, welcome back to my YouTube channel. So just over a week ago I uploaded part 3.1 of this custom compressor, this beast, this project. Then a few days later, or a few days after that, part 3.2 was uploaded. If you haven't seen these two most recent parts yet, or the two parts before that, the tumbling process, do get a look. They are quite interesting and heavily detailed. I previously had to split part 3 into 3 smaller sections. Part 3.1 focused on the selection and the mounting of both motors, both pumps, both V-belts, and finding the correct pulley sizing for optimum performance. In that part, I also routed the main supply lines from the pump's aftercoolers to the vessel's check valves using industrial grade tube and fittings. Near the end of that video, I created a bonus clip that demonstrated the system in which the custom compressor build will be fed into. In part 3.2, I focused on the attachment of all the pneumatic accessories while seating all the joints and the threads, including the new 3/4 inch vessel supply pipes and fittings. I also added other important pneumatic drain pipes to get this system to work as it should. When that was all complete, I focused on the electrical side of things. So in this final part, 3.3, I will continue with the electrical work before finally testing the custom system. Please bear with me. I had fallen ill at the end of this part, just before I started creating the new motor, the belt tensioners, that are briefly introduced, seen near the end of this video. The design and the manufacturing of those smart mechanisms will appear in, part 4 video. That will follow very soon. So here we go. I will start where I left off in part 3.2. Okay, so I'm going to run the cables from the left-hand side of the vessel to the right-hand side, where I will meet the switch, the pressure switch at the right-hand side of the compressor. So I have to do the pressure switch first before I can place this second motor back on the platform. The blow-off valve, the cable for it, will be just sort of run down this side of the vessel as the blow-off valves down here. So we'll cable tie this up, we'll wire it in, and then we'll mount the second motor. Okay, so that's the pressure switch wired. I will set this cover on for now, but it does need to come off again for the adjustment here at the top of the pressure switch. So that's to control the amount of pressure within the vessel. So we'll leave that like that. We'll mount the motor now. Okay, so the next cable I'm going to attach here is the one for the blow-off valve. Okay, so just a wee demonstration here before I move on. So I need to run the two cables now to the motors. So what I'll do here is I'll remove these covers I will place the heavier 2.5mm cable into these glands, and I will run it down here and down the two cables that's already attached to the compressor. So we have approximately 4 meters of length from the end of the left hand side of the compressor to the end of the cables. So I'll do this now. I will remove these covers and we'll get started here. Okay, so I'll start off here with motor number 1. And now motor number 2. So we'll tighten these cables up now before we start wiring these up to the motors. So I've got these lovely yellow cable ties to match the cable. Okay, so before I go any further with cable tying the cables going to the control panel, I'm just going to wire these motors up now to be done with it. So here we go. Okay, so that's one motor wired. So let's say that when I turn this motor on, the actual belt runs the wrong direction, or the pulley. All I need to do here is switch these two plates on the terminal block across these terminals. So basically turn them 90 degrees, this point and this point. Okay, so motor number 2. Okay, so that's the two motors wired. So we'll go back to this cable now and tidy everything up here and wire the plugs on the end of the 4 of them. So we'll do that now. Okay, so I'm just going to level these up now to the shortest cable, which is approximately 4 meters from the vessel, the compressor. There we go. So we'll wire these sockets on now, or sorry, the plugs, and then we'll move on and do the final touches to the compressor before we turn it on. So that will be pouring the oil into the pumps. First things first, I'll cut all these cable ties nice and neat. Okay, so I nearly forgot about wiring the blow-off valve, so I will do this now. Okay, so that's it. Moving on now to the plugs on these cables. Okay, so with the plug wired, I'm going to place this timer onto the solenoid. The solenoid controls the valve and the timer controls the solenoid. So this solenoid is only powered up when the timer controls it or when the timer activates it. But the timer has power when the isolator of the compressor is turned on. Okay, so just a wee sample here of the wiring complete going to the vessel. So we have this cable, this 1.5 that I just wired, going to the solenoid in a nice, neat curve. So we're now going to move on to these plugs at the other end of the cable here. So we have 4 plugs, and then we're ready to fire this compressor, this beast up, but only when I get the oil in the pumps first. Okay, so I'm now ready for that final stage. It's been a long haul, but I'm finally here. So we have 4 cables and 4 plugs. We have 2 32 amp for the 2 motors. We have a 16 amp for the blow-off valve, and we have a yellow 16 amp for the switch that controls the control panel. So basically it controls the motors via the contactors. So I have the cable marked here to indicate it's running to the solenoid and not the switch. So we will trim these and we'll get them wired here. Okay, so this blue 16 amp goes to the solenoid on the bottom of the compressor for the blow-off valve. We have this yellow one for the switch on the other 1.5mm cable. Then we have these large 32 amp plugs on the 2.5mm squared cables. So we'll put little bootlace connections on the end of each one of these wires now. Then we'll get them wired here. Okay, so that's the 2 16 amps done. Now on to the 32 amps. Okay, there we go. So these should be roughly the same length. If not, we can just push these cables in a little bit into the plugs. Like so. There we go. Good job. So oil now in the pumps. Okay, so I have the sockets and the plugs ready. I have the control panel ready. Everything is ready. The last thing I need to do here is pour the oil into the pumps. So each pump requires 900 milliliters. So we have this high grade oil, as I mentioned earlier. We also have this little gauge to work with. Okay, so you might be able to see that rising on the bubble there now soon. So we want it to be sort of in the center of the bubble. So there's actually a wee red ring in the center here. Okay, so we're about a quarter of the way up. That will do for now. Actually, we'll pour a wee bit more in and we'll move on to the next pump. So we're just at the bottom of the red ring. It's taking more than I thought it would take. So we're nearly at the center now. That will do. We don't want to overfill it here too. Next pump. Okay, so pump number 2. So that's it now, rising on the bubble. Okay, we're nearly halfway. I think that will do it. Yeah, perfect. Okay, so just a wee sample video here of the oil level. So both pumps, we have the oil sitting at the top, well nearly the top of this red ring. We don't want to fill out too much, we don't want to abuse the pumps. So here's the second pump. Okay, so my next step here now is checking if these motors are running the right direction before we place the belts onto the 2 pulleys, or the 4 pulleys shall I say. One last thing I want to point out. So this is where the compressor will sit within my garage. So here we have the outlet of the vessel. This will connect directly to my system, like so. So that compressor used to sit up on the stand, on the wall, but because of the headroom now and the height of these larger pumps, I'm going to keep it on the ground. Well, we will see. I might change my mind in the future. I will double check the measurements and take it from there. So we're on to the panel here now. We're going to start this thing up soon. We'll test the motors. So where do I start? Okay, so I'll start here at the panel. So if I turn this isolator switch on, that panel now is powered up. If I turn this switch on for motor 1, this light should light up, but it's not lighting up because we don't have the switch on the compressor connected with this plug and this socket. So that switch, I just want to point out, is a normally closed switch. When the compressor is down in pressure, when the vessel is down in pressure, this will be at its normally closed position. So I'm going to put the camera on the stand here and do a wee demonstration, and hopefully this works as it should. I will aim the camera up to the panel and I will basically place the socket and the plug in my hand here. So, what do we see? So hopefully you can see everything nice and clear there. So when I plug this switch now into the socket, we should see this first light up. There we go. So that means now that contactor 1 is engaged. So motor 1 should be running, but I don't have the plug plugged into the other socket on the near the ground here. So when I flick motor 2 on, this should light up here only after the delay. There we go. So there's a 4-second delay on at the minute. So that's all working as it should. So my next step now here is plugging this motor in, motor number 1, and checking it works, it's running the right direction. So I'm just going to guess here, this is motor number 1 lead. So I'm going to guess this is motor number 1 and not motor number 2 for the meantime. There we go. So that's 2 plugged in. I will aim the camera to the ground there. And what I'm going to do here now is I'm going to turn this on. So the first switch and one of these motors should kick in. There we go. So that's the first time that this has run. So I'll take the camera off the stand here and it's running the wrong direction. So I'll turn it on here again. Let me see. So it's running clockwise. I need that running anti-clockwise, looking at it from this side. So I need to switch these 2 plates in both motors. Okay, so I'm going to do that now, and then we're going to connect this up properly and get the motors running in the right direction. Then we will place the belts on the 4 pulleys, or on the 2 platforms, shall I say. So I'll do that now. Okay, so both motors are turning clockwise. We have an arrow here on the pump, which tells us that these pumps need to turn anti-clockwise. So what I'm going to do here now is switch these two plates on the terminal blocks on both motors. Then we will plug in the 4 sockets, and then we will place the belts on the pulley. So we'll put the camera on the stand here, we'll change these plates, and then we'll move on. Okay, so I'm going to start here with motor number 1. So the panel here, the isolator switch is off. Here we go. We'll tighten these nuts up. Place the washers on first. Okay, so I will continue on here with motor 2. I will do it off camera here. Okay everyone, so it's been a week since I worked at the compressor. I've been lying on my bed sick with a really bad dose of the flu. I'm still sick, but I need to continue on here because if I don't, I'll never get it done. I want this compressor done so I can get on to new projects. Okay, so the final part of this video will be performing a little bit of fabrication. I can't even get my words out because I'm exhausted. So what I'm going to do here is I'm going to make a special bracket to adjust the motor and in turn adjusting the belt or the belts on this tandem compressor. So I'm not going to include all that work in this video, but I'm going to include the final piece, the little parts that, or little mechanism that I'm about to make here. So I'll bring the camera up close and give a wee discussion of what exactly it is that I need before I move on. So hopefully my voice keeps up here. So I'll bring the camera up close. Okay, so here we go. So these compressors, usually you tighten the belts by pushing the motors on slots that I demonstrated earlier in this video. But the problem is here now, these motors are quite big, and when you're pushing them, it's kind of difficult. What usually I would have done here is leveraged the motor away from the pump using blocks of timber and a pry bar. But I don't want to do it that way no more, because for one reason, when you pull this motor away from the pump to tighten this belt, the belt usually stays twisted because of the actual tension in the belt. So if you can imagine, when I'm pulling this motor this way, it's not going to stay straight unless you tighten this bolt first and then push this end of the motor this way and then tighten this bolt. It's kind of tricky. So what I'm going to do here now is I'm going to make 2 brackets, well, 2 mechanisms. I can't even get my words out. What do we see? 2 types, or 2 of identical mechanisms, I should say, that will adjust these motors the way I want them. So there'll be no messing about here. So I'm just going to, I think I have 2 images here, yeah. So this is what the little mechanism will look like. Well, there'll be 2 of them. So we'll have 1 bracket, 2 bracket, 3 bracket. And basically what I will do here is use an Allen key. I think it's a 6mm Allen key and an M8 thread bolt. So when I adjust the bolt back or forward, it pushes and pulls the motor at both positions. So that's a little 3D drawing there done on SolidWorks. My voice is sort of going there. Here we have a colored version, and here we have another different orientation. So I've made the brackets out of paper, or sorry, I've mimicked them out of paper for the meantime. So basically, we will have these two pieces on the motor. We will have this long bracket bolted to the top of the vessel, the platform. And what I will do is adjust the Allen key, the cap bolt, to move the motor back and forward. So I'm going to start that now. So the next video clip here, these two brackets will be complete. As I say, I will do all the work and I will add it to the next video, part 4 of this project on my channel. So here we go. Okay, so I have the tensioner mechanisms complete. They are incredible, they work really well. As we can see, the belt is now tight, or the belts. So 2 mechanisms, one for both workstations. So what I'm going to do here now is I'm going to put the camera on the stand and I'm going to do the initial startup of the compressor. So I haven't run the pumps at all yet, and the reason being is I want to just go through everything in detail here, just in case there's a leak or something doesn't work right. So things could go wrong. So the camera on the stand here now, if you want to see detailed design and manufacturing of these brackets, the entire mechanism that adjusts the motor, both motors, please see the video that follows. So that will appear in the next week or so. Well, a week after this video. So I'll put the camera on the stand here and I'm going to do the startup, the initial startup. So hopefully this goes well. We'll take her back a bit here. So I have earplugs in. Away we go. So both switches are on at the panel. The main isolator is off. No, sorry, it's on. So the only thing I need to do here now is pull up this switch on the pressure switch here. So this wee red sort of knob. So here we go. First pump going, first platform, the delay, second one. Incredible. So what I'm going to do here is I'm going to time this, building up the pressure. Hopefully you can hear me. Quite fast. Hopefully there's no leaks. So this pressure switch will put out probably around 100 psi. I think that's where factories have them set roughly, but I will adjust it on up to 150 psi. The tank's rated to 11 bar, which is higher. I'll put the camera back in the stand here. I'm going to stand back for a moment. Look how fast that thing's filling up. Mental. So it's at 110 psi. I hope this blows off. So I'm just going to stand outside here, around the corner, for a moment. There's a safety pressure switch, or safety valve on the vessel, but I'm just going to stand out anyway. So it's mental, it's already at 130 psi. 140. Whoa. everything works as it should. That is absolutely mental. So she's sitting at 140 psi and there's no leaks. I can't believe how quick this thing has filled up. It's amazing. The old setup was, well, it took ages, twice the length of time. So this vessel was completely empty there. So that's really, really, really good. So I'll just bring the camera up close here again to do this final wee part here. So I'm just going to sample the air coming out of this port. So all I need to do now is connect that up to my line in my garage and up to my system. So that's it, everyone. I hope you enjoyed. What I might do here is do one final test. I might screw this pressure switch up to 150 psi. Then we will do another startup test. So I'll drain the vessel here first. Okay, so for this second test run, I have adjusted the pressure switch. So I've turned the screw, the bolt, the 10mm headed bolt, within or underneath this cover, approximately 4 turns clockwise. So that should take the vessel up to around 150 psi or thereabouts. Okay, so the vessel is now drained. The gauge is reading 0 psi. We have the 2 switches on. So let's say that I wanted one pump station going. So I would keep one of these switches on. So this will be pump 1 and this will be pump 2. So this switch has a 4-second delay, or this pump has a 4-second delay between this one starting. So let's say that I wanted to run 25 CFM and not 50 CFM. Well, I just keep one of those on. Just want to point that out. Another thing I want to point out here is, before we move on, we have these blow-off valves, which I didn't realise what they do until the compressor shut down the last time. So they regulate the pressure within the head of the pump, very similar to what this pressure switch does. So it drains the lines that I built, that I created here, when the compressor shuts down or when the compressor balls up to its maximum set PSI. Another thing I want to point out, so we have this blow-off valve. It's working as it should. The test button there, so you can hear the valve clicking, then the solenoid powering it. So yeah, we're going to move on here now. We're going to start this up. So with the camera back on the stand, I just want to point out there, the last time that I demonstrated here in the video previously, you can probably tell that the compressor doesn't seem overly loud. That's because I am using well, a special microphone here. It has noise cancellation on it, it has filtering on it. So what I'm going to do here when this thing's running, I'm going to disconnect the microphone and use the camera's microphone to get a real feeling of the sound of the compressor. So it's not overly loud, but it's loud enough. It's louder than what the camera is making out to be with the microphone. So I'm going to turn this on again now. So here we go, switch up. We're going to see how quick this builds up to 150 psi from a drained tank or drained vessel. Second one going, see the lights dimming there? So, I'm going to disconnect the microphone. got to 100 and, let me see if I move this cable. It got to 150 or 148 psi. So I could turn the pressure switch up a wee bit more, but I might just leave it there. So that's it, everyone. Okay, so I nearly forgot to do a wee demonstration here of this blow-off valve blowing off. So I'm going to push the test button. So that's the way it should operate every 45 minutes. So all's good. So that's it, everyone. An additional part 4 video will now follow, dedicated towards the design and the manufacturing of both these stainless steel tensioner mechanisms. But also it will be focused on the stainless steel safety guards that I have not produced yet. So this may be 1 guard, 2 guards, 2 pieces, 4 pieces, 6 pieces. I haven't got there yet to make my mind up on that part. I might even split these future videos into 2 sections. This might be a good idea considering the extensive amounts of detailed work involved in all areas of this project. Here is a wee teaser of the stainless steel mesh, the material I will use to form the guard or the guards. Again, like everything within this project, it wasn't cheap. So the profile of this mesh is 3 inch by half inch, so you don't get your fingers through the holes. The material type is 304 grade stainless, so it's an 8x4 sheet. So I can't wait to get this part of the project started. So this will be the finishing part of this custom project. So as I say, I need to now perform manufacture 2 custom guards or 1 custom guard for this custom setup. If you want to see this project Beast evolve, please subscribe and hit the post notifications bell to see all the latest from my channel. Also, other interesting projects will follow very soon, such as my one-of-a-kind green e-bike Beast, and also my unique mechanical iris by Aperture and my unique smart glove. So I have a lot of work ahead of me. Okay, so I know this project run on a little long. I wasn't expecting to do all this extra work, such as these tensioners. But like I mentioned before, you won't see these kind of projects anywhere else. The tremendous dedication towards all these projects is something I've worked for since a young age to achieve the things I do lonesome. Watch this space, it's only beginning to get more exciting. Thank you and goodbye.